All right, welcome to Thursday's lesson. Make sure you got your warm-up, the note sheet, and the Bitly paper I'll give you while you're doing this. Number one, a graphic designer is able to design 3/4 of an order in 4/5 of an hour. Right there, two numbers in the same sentence make our given ratio, and they'll help us out with our ticket. We want to see how many designs could they make in 1 hour. So again, comparing orders to hours, that would be our units or our ticket. We're plugging in our given ratio, 3/4 of an order, 4/5 of an hour. We want to see how many orders, we don't know that, in 1 full hour. Well, we're going to cross multiply. We're going to get 4/5 x is the same as 3/4. We're isolating x by dividing each side by 4/5. Off to the side, the real division problem was 3/4 divided by 4/5. We keep change flip. We get 3/4 times 5/4, and we end up with 15/16. Does not reduce. Final answer. Number two. Angle A and B are complementary. Right there, they're trying to tell you what they combine to make. They are 90-degree angles when they are added together. Angle A, 2n minus 10. Angle B is 20. So again, a picture would really help you out with this problem. So, complementary right angle that makes a 90-degree angle. One angle, 2n minus 10. The second angle is 20. We combine like terms correctly. This is probably the hardest part of this problem, is making sure that you have -10 plus 20. That gives you +10. So the real problem is 90 is the same as 2 times n plus 10. First step to start isolating an n, we got to subtract each side from 10. So 90 minus 10 is 80. 80 is the same as 2 times n. The opposite of times 2 is to divide by 2. And we're going to find out that n is 40. We plug that back in. 2 times 40 minus 10 is 80. Now we have an 80-degree angle and a 20-degree angle. Together they form a 90-degree complementary set of angles. Number three, a ticket problem. But really what it boils down to is just a long division problem. So we're comparing the total cost to the yards of fabric. So again, I just took the easiest ratio, would probably be the first one, because you got to know your 7 times tables, your 12s, or your 15s. Again, 7's probably going to be the easiest. So again, 7 goes into 1652. Well, 7 goes into 16 twice. We get a remainder of 2. Drop down that 5. 7 goes into 25 3 times without going over. 7 times 3 is 21. Remainder of 4. Drop down to 2. Goes in 6 times evenly. We get an answer choice of A, $2.36. And last one, mean median. Again, making the list, going through, locating the mean. The mean is 51.25. The median is 49.5. Done, warm up right there. Make sure that you've taken your notes. If you got to go back through and copy any of them, make sure you do so before you start today's lesson. All right, today we're going to talk about inequalities. We're going to go through graphing, solving, and solution sets. So, first one here that I'll model for you. N is less than or equal to -4. Remember, that line underneath lets us know that it's or equal to. Well, first thing, let's come up with 3 numbers that make this true. Well, again, I need 3 numbers that are less than or equal to -4. Well, the first number that's less than or equal to is -4 itself. Now, less than, we're looking to the left of -4. Well, if I think about a number line, the numbers to the left of -4 are -5 and -6. Okay, common mistake is that people think it's -3 and -2, but we're actually getting closer to 0 in the positive numbers. And we know once we get into the positive region that we're definitely dealing with greater than numbers. Second thing, I put a little hint here. Well, which symbol we have less than or equal to. So again, we got to fill in that circle. So when we go to graph this, we're going to start our graph at -4. That's our boundary where it starts at. And then I'm going to use a filled in circle because of this or equal to part. -5 and -6 are to the left. So we would have a closed circle starting at -4 going to the left of -4. Okay, second one. Again, we have 16 is less than x. Well, if 16 is less than a number, I got to think, what kind of numbers would make x true? Again, we said less than, but if I put a number like 15 or 14 there, 16 is not less than 15. 16 is not less than 14 or any number to the left. So actually, which number makes this true would be 17, 18, and 19. The first 3 integers that are greater than 16 are the first 16 is less than x. Again, this makes sense because 16 is less than 17, yes. 16 is less than 18, yes. 16 is less than 19, yes. Again, our number line is going to start at 16. This time I have just less than. So I know I'm going to need an open circle to denote just less than. And again, I got to think about where are these three numbers located? Well, 17 and 18 and 19 are to the right. So again, it would be an open circle because of less than, and these numbers go to the right, so it would be an open circle to the right. Go ahead and pause the video for a minute. I'd like you to try these 5 problems. Graph, just like I did, come up with 3 numbers, go ahead and put them to the left or to the right, and then answer the question down below, similar to what you could see on your EOG at the end of the year. When you're ready, unpause the video, and I'm going to go over these ones. Okay, so first one, x is greater than -4. Well, 3 numbers that would make that true. I know the numbers that are greater than -4 run to the right of -4, so I'm looking at like -3, -2, and any positive number. I'll put +5 there, just so we get a little bit of a bigger range. Again, this graph's going to start at -4, where it tells us to. We need an open circle because of greater than, and these 3 numbers all run to the right of -4. -3, -2, and we know -5 would be somewhere over there. Second one, x is greater than or equal to 12. This one should be a little easier because again, we're dealing with positive numbers. Well, the first number that's greater than or equal to is 12 itself. And then you could use like numbers like 13, 20, 100, a million. It doesn't matter as long as they're larger than 12. Again, my graph's going to start at +12, where my boundary told me. This time, because I have the or equal to, I need a closed-in, filled-in circle. And these 3 numbers, well, 13 and 14 and 20 and all those numbers all run to the right, so it would be a closed circle running to the right. Bottom 2, we have x is less than or equal to 1. Well, again, 3 numbers that make that true. Well, the first number that's less than or equal to 1 is 1 itself. And then 2 numbers that might be less than 0, and then really any negative number would make this true. So again, I'll use -4 just to give us a little bit of a range. Graph will start at +1. I'm going to use a filled in circle because we have or equal to. And again, if I plot these numbers, they run to the left. So it would be a closed in circle going to the left. And last one, like these ones, we have x is less than -4. So again, 3 numbers that make this true. We would have to use -5, -6, and maybe like -10. Again, they run to the left. They are all less than. They are progressively getting more negative. We start our graph at -4. Again, -5, -6 would all be to the left. So it would be an open circle because it's just less than, not less than or equal to, so an open circle run to the left. Really important that you know how to graph and solution set because the solving part is very similar to how we solve equations. Down below, if we saw something like this, we'd have to think to ourselves, well, we know it's an open circle and it's starting at -6. Just based off that, well, actually, there's one little mistake. We should have -6 here for all these. Just based off that it's an open circle, I can easily eliminate a couple choices. So I know that it's not or a closed circle, which would be or equal to. And then I'd have to think, well, what are some numbers that are to the left of -6? Again, any number to the left is less than, it's progressively getting more negative. So I know it would be like -7 and -8. So again, these numbers are getting less than. Well, which one has x is less than -6? That would be answer choice D. C is the opposite. Oops, C should have been greater than, something like that to throw you off. So sorry for the wrong answers, but again, just trying to show you what an EOG question would look like. Something where they're just going to ask you, hey, what graph is this? Which inequality represents that? All right, moving along. Inequalities, solving them. Again, as I said, the steps that we're going to take are almost exactly the same. We're going to isolate a variable, inverse operation, and golden rule. Whatever we do to one side of the inequality, we're going to do the exact same thing to the other side. The only extra step that you have to throw in is when you're multiplying or dividing by a positive, the symbol is going to stay the same. Anytime you're multiplying or dividing by a negative coefficient, you have to end up flipping the sign to make it a true statement. We did a little research thing back when we went over this, and we proved that that was definitely true. So, first one, again, first thing I want to see, what kind of coefficient variable do I have? I have a positive 4 times x. So I know at the end, this symbol is going to stay exactly the same. So one strategy is down by where your answer is, go ahead and write, hey, I know the variable started on the left, I'm going to keep it on the left. I know that the symbol is going to stay the same because I'm going to divide by a positive 4 at the end. So I'm going to just drop down. That way I don't end up messing up or having to get confused at the end. First step, we have to get rid of this plus 5. So again, just like an equation, the first step, get rid of our pluses and minuses. So positive 5 minus 5 cancels out, goes away. I have 4 times x is less than or equal to negative 15 minus 5 would be negative 20. I have 4 times x, so again, I'm going to divide each side by positive 4. That's why my symbol stayed the same. 4x divided by 4 is 1x. Negative 20 divided by 4, negative 5. So to solve this, the final answer would be x is less than or equal to negative 5. Second one on the top right. This time, I have to be careful. I do have a negative coefficient. This is a negative 1 times x. So I know that at the end, again, my variable started on the left. It's going to stay on the left. But this time, greater than or equal to is going to end up flipping to less than or equal to. Well, when I go to solve it, I have a positive 6. Well, how do I get rid of a positive 6? I subtract 6 from both sides. 6's will cancel out. Negative 1 times x is still greater than or equal to 2 to minus 6 is negative 4. Again, I can't have a negative coefficient. The x is not by itself still. So, how do I get rid of a negative x? Well, this is negative 1 times x, so if I divide each side by negative 1, again, my sign will flip because I'm dividing by a negative, and negative 4 divided by negative 1 is positive 4. So we would end up with a final answer of x is less than or equal to positive 4. Bottom two, I would definitely try to pause the video, see how you're going to do with these two. Again, they are very, very similar to the ones that I did just above, but I would take a second and try a couple of these on your own before you get into today's assignment. When you're done, unpause the video and we'll get started. So, again, here, I have a negative coefficient. I know that because it's a negative 3 times x. Well, this one, again, I have to be careful. The variable's on the right side of my inequality. So when I solve this, I need to make sure that my variable stays to the right of the symbol. But because I have a negative coefficient, I know that this greater than is really going to flip down to less than. Again, to solve it, whatever side the variable's on, in this case it's the right side, I got to start undoing inverse operations over here. So I have a minus 11, means I got to add 11 to both sides. Negative 11, positive 11, cancel out. Over here, I have negative 12 plus 11. That is negative 1. Negative 1 is greater than negative 3 times x. Last step. Again, I know that the variable is going to flip because on this step, I'm dividing by a negative 3. So my inequality flipped from greater than to less than. Negative 3 times x, divide each side by negative 3. And this one may end up giving you a decimal, 0.3 repeating. But what I would do is just hit FD and you're going to notice that's really just 1/3. So we can say that 1/3 is less than x. Or x is greater than 1/3. We would just flip everything around. But in this case, we're going to leave it as it looks. And last one. Again, I have to see that I do have a negative coefficient. Again, my variable's on the right, so it has to stay on the right. I'm going to divide by negative 5. So again, this greater than is going to flip to less than. To solve, I have positive 5. Well, to get rid of a positive 5, I subtract 5. The 5's will cancel. 10 minus 5 is still positive 5. Is now greater than negative 5 times x. Again, I'm going to divide each side by negative 5, and because I'm dividing by a negative, that's why my inequality sign flips. 5 divided by negative 5 is negative 1, and we can say that negative 1 is less than x, or again, x is greater than negative 1. No real need to flip it around in this case, though. Again, make sure you have all the correct answers on your sheet. We're going to try a couple of these. I'm going to try the one on the left, or show you the one on the left, and I'd like you to try the one on the right on your own. This will be the last thing we do before we get into today's assignment. So, no real difference other than this inequality. If I had just covered this up, everybody would know exactly what to do. We're going to distribute the negative 2, combine like terms if we can, but in this case, we're actually going to solve for x, but the first thing we got to do is we got to set up the two-step inequality. So, first step, anytime I have that outside number, I'm going to over, under, and I'm going to distribute it with multiplication to the inside. Negative 2 times 4x is negative 8x. Negative 2 times positive 6 is a negative 12. I'm going to just drop down the rest because none of this, the inequality sign or the constant side, are inside the parentheses. Once I have it set up, again, solve it just like we did earlier. So, again, I'm going to recognize I have a negative coefficient with a variable. So I know at the end my sign's going to flip from greater than to less than. I know that x started on the left, it should end on the left. First step, minus 12, the opposite would be to add 12. Negative 8 times x is greater than 27. And this time we have to divide by negative 8 on each side. When you do that, I'm going to need a calculator. Should you get a decimal or fraction answer, 27 divided by negative 8 is negative 3.375. And that would be our final answer right there. Scroll up so you can see all the notes for that problem. Okay, what I would do at this point is, again, pause the video, try the one on the right, see how you do before you get into today's assignment. All right, second one, once you're ready. Again, first step, over, under, we got to make sure that we set up the problem correctly. Negative 3 times 2x is negative 6x. Negative 3 times negative 2 is positive 6. Again, I'm dropping down the inequality sign and the constant side. From there, again, I'm going to recognize I do have a negative coefficient with my variables. So again, at the end, I know x started on the left, it ends on the left. Less than is going to flip to greater than because of my negative coefficient. First step, I have positive 6, so I'm going to subtract 6. The 6's will cancel. Negative 6 times x is now less than negative 24. I have times negative 6, so I'm going to divide by negative 6. And x is now greater than positive 4. Okay? Again, make sure you have all your notes. If you got to go back through the video and fill anything out, you can. By now you should have a bit.ly paper. I left a little bit of graphing solution help on there. And you also have your second bit.ly both on the first page and the last page here. So when you're ready, start the other bit.ly. Raise your hand when you're finished.